Good morning, everybody. Today, we have to learn the method of least square, method of ordinary least square, OLS method in econometrics. Myself is Manoj Kumar Singh, and I am teaching econometrics for Indian Economic Services. So first, we shall learn the method of ordinary least square. What is this? Why it is needed? So this concept has been given by Carl Friedrich Gauss. This is also called Gaussian method. This is a very important tool of statistics, and that's why this one is very popular method. This gives the best fit of the line. Like we draw the regression line. I want to explain you this concept with example. Suppose this is a consumption function, and you know well, right, this one is the consumption function, okay, but this line denotes the consumption function, whether the line will go from upward, downward. The line will be more flat, more steep. Therefore, in consumption function, there are two parameters, A and B. A is called intercept. Here is A. This one is A. And B is called slope. But we cannot, without using this method, we cannot know how this line will pass through. Therefore, the best least square method is the best method which decides how this line will pass. Second thing is very important, like consumption function, you see, consumption is a function of income. Normally we write here C equal to function of, in linear term, A plus B by D. This one is a disposable income. Consumption is a function of disposable income, and B is the called intercept. Okay, but consumption is also a function of not only disposable income, but rather consumption is a function of disposable income. If we denote it at x1, consumption is also a function of past income. This is x2. Consumption is also function of price. This is x3. Consumption is also a function of size of the family. Like x3. Consumption is a function, also function of religion. This is x4, x5. Consumption is also a function of like social status. That is x5. So this we compute consumption only as a function of disposable income. But these variables also impact the consumption. Then these all are called stochastic variable or random variable, but these all have impact on this consumption. Therefore, how this line will pass, Hence, we use the method of the least square. We see one another diagram, then you can get more better concept. The another diagram is like this. The another diagram is like this one is a curve, and this denote y estimate equal to beta 1 estimate plus beta 2 estimate xi. Here we denote x variable and either y. Again here x is income, we denote here income level, and here is consumption. Consumption, right? We take the value of x here like this one, we have a data sample of x and y, x and y. We are plotting the value of y with respect to x. So like you will get like this. Some points are on the line, some points are below the line. Like this one. Okay. So if you denote it like this is U1 estimate, this is U2 estimate, U3 estimate, U4 estimate. Okay, means if all the points which we are drawing or all the variables with respect to income and consumption, all points falls on this very line, there is no problem. But some are above the line, some are below the line. Then how to draw the exact line which represent all the variables? Okay, all the random variables. It is very difficult one to draw the line. Therefore, it is the method of the least square. This method given by Gauss, Carl Friedrich Gauss, gives the exact line which represent all the values. Therefore, this method of ordinary least square is used. Now, we shall explain this concept with a population regression function. Our population regression function is like y beta 1 plus beta 2 xi plus ui, where beta 1 denotes the intercept and beta 2 denotes the slope. This is a population line. Population regression function has been derived for the consumption function, and x is the, suppose x is the income and y is the consumption level. But since population is very wide, it is very difficult to get information and calculate the values of beta 1 and beta 2 through the data of the population. Therefore, we take sample, and after taking the sample of x as well as y, we again draw the sample regression function. Then the sample regression function, this is called population regression function. From this population regression function, we draw the sample regression function like y equal to beta 1 estimate plus beta 2 estimate xi plus ui estimate. This is a sample regression function. Okay. Now, my problem is how to get the value of beta 1 estimate and beta 2 estimate. Means beta 1 estimate, as I said you, this denotes the intercept, and beta 2 estimate is the slope. These two values are very important to draw the regression line. Okay? So, how to compute the value of beta 1 estimate and beta 2 estimate? This value can be drawn like this. Suppose now we compute it through this sample regression function. We can write this equation also like this: y equal to y estimate plus ui estimate, or ui estimate equal to y minus yi estimate, or ui estimate equal to yi minus beta 1 estimate minus beta 2 estimate xi. Okay. Right? Since ui estimate, what we have done? We have subtracted the estimated value with actual value. This one is the actual value. This one is the actual value. Actual value. Actual value. And this one is the estimated value. This one is the estimated value. Then this difference is the ui is the random variable. This is also called a stochastic variable. Then we have to minimize it. What is meaning of this? Some of the random variables are like this. Some of the random variables are above the. Some of the random variables are like this. Above the regression line, some are below the regression line, some are on the regression line. Then how to minimize it? What will be the best way? What will be the average from where our regression line will pass? Therefore, to know this, if we square, some of these points are positive values, some are negative values. If we square the negative, this will be positive, and positive itself is positive. Therefore, you square it, and by using the method by maxima and minima. Now, our problem is ui. Our problem is ui estimate equal to yi minus beta 1 estimate minus beta 2 estimate xi. Okay. Taking summation both sides and squaring both sides. If you square UI estimate square, then all the values will be positive, and this one, after squaring this and using the maxima and minima. So as you know, by maxima and minima, for my problem is not minima, my problem is maxima. This is my problem. So how to get this condition for maxima? First condition is partial derivative. We shall take the help of the partial derivative, that is del UI estimate square by del beta 1 estimate 0 and del UI estimate square by del beta 2 estimate equal to 0. This is the first order condition. And second order condition is this del UI estimate square by del square UI estimate square by del beta 1 estimate square must be negative, and similarly del square UI estimate square by del beta 2 estimate square must be negative. This is the condition through maxima and minima that will give the exact value of beta. This will give the two regression equations. So first we shall draw the two regression equation. After that we can get the value of beta n1 and beta 2. Okay. Now this we differentiate it. Del UI estimate square by del beta 1 estimate equal to summation yi minus beta 1 estimate minus beta 2 estimate xi square. If we differentiate it partially with respect to beta 1, this will be the value by using the chain rule. By using chain rule. What chain rule says? Chain rule says that if y equal to function of w and w equal to function of x, then del y by del x equal to del y by del w into del w by del x. Okay. By using this function into function rule, we can solve it. We can get the normal equation, then you differentiate it, you will get this value to summation yi minus beta 1 estimate minus beta 2 estimate xi, and you are differentiating beta with respect to beta 1 estimate. This will be minus 1 equal to minus 2 summation yi beta 1 estimate beta 2 estimate xi. By first order condition, del ui estimate square del beta 1 estimate equal to 0. Okay. Then what will value be? Then equal to minus 2 summation yi minus beta 1 estimate minus beta 2 estimate xi equal to 0. Then minus 2 will be eliminated and we shall get the value how much? Yi minus beta 1 estimate minus beta 2 estimate xi equal 0, or yi equal to beta 1 estimate plus beta 2 estimate xi. This is the first equation. Okay. So we have got the first equation, and similarly we shall get the second one. Now our first equation is yi equal to beta 1 estimate plus beta 2 estimate xi. Here we have forgotten the summation, then this will be summation yi n beta 1 and summation xi. This will be again summation yi n beta 1 estimate and summation xi. So this will be summation yi beta 1 n beta 1 estimate plus n beta 1 estimate plus beta 2 estimate summation xi. This is your first equation. This one is the first equation. Now we have to second normal equation we have to draw. This is the first normal equation. The second normal equation we can draw again differentiating with respect to partial differentiation with respect to beta 2. So del, this is this one is del ui estimate del beta 2 estimate equal to how much it will be? Now you differentiate it. So this will be the value equal to del by del beta 2 estimate summation yi minus beta 1 estimate minus beta 2 estimate xi. This will be equal to, if you differentiate it, 2 summation yi minus beta 1 estimate minus, you are differentiating with respect to beta minus beta 2 estimate, which you are differentiating with respect to beta 2, there will be, it will be minus xi. Then minus 2 summation yi minus beta 1 estimate minus beta 2 estimate xi and into xi. Then now by the, you multiply this xi equal to minus 2 summation xi yi minus beta 1 estimate xi minus beta 2 estimate xi square. Okay. By first order condition, first order condition of maxima, what condition is? Del equal to del ui estimate square by del beta 2 estimate equal to 0. So this term will be minus 2 summation xi yi minus beta 1 estimate xi minus beta 2 estimate xi square equal to 0. Then the minus 2 will be 0 and you will get how much? Summation xi yi minus beta 1 estimate summation xi minus beta 2 estimate summation xi square, and this will be equal to, this will be equal to summation, this will be equal to summation xi yi equal to beta 1 estimate summation xi plus beta 2 estimate summation xi square. Okay, you have got two normal equation. You have got two normal equation. This one is 2. After solving this two normal equation, you can find the value of beta 1 and beta 2. Now we have the formula for beta 1. Beta 1 estimate, how to compute it? So directly you can compute the value of the beta 1. So like this one is the value of, this one is beta 1. So beta 1 equal to, just you multiply this term, you delete this one beta 1, this portion, this one is something, wait. Yeah, yes. Now you can get a value of the beta 1, this one. So you multiply this summation yi xi square, okay, into this term summation xi into summation xi yi, and divided by n summation xi square minus summation xi whole square, and value of the beta 2 estimate equal to, now here is the beta 4, so that is n summation xi yi minus summation yi into summation xi whole divided by n summation xi square minus summation xi whole square minus summation xi whole square, okay. By this way you can get the value of beta 2 and beta 1. You can also have the value of beta 2 and beta 1 like taking the deviation through from the arithmetic mean. Then you can, this is a beta 2 estimate equal to summation xi yi by summation xi square, and this is equal to summation xi minus x bar into summation yi summation yi minus y bar, and whole divided by summation xi minus x by square. Through this formula you can also get the value of beta 1 and the value of the beta 2, and value of beta 1 directly you can get y bar minus beta 2 estimate x bar, okay. These are the formula by which you can get the value of the beta 1 and beta 2. By using these parameters, value of the parameters, values beta 1 and beta 2, if you draw the line like this one, if you draw the line like this one, this will exactly pass through the middle of the, this is y estimate equal to beta 1 estimate plus beta 2 estimate xi, okay, and this one is intercept beta 1 estimate, and this one is the slope beta estimate. This one is a y and this one is x. This is called method of the least square. This is called also the method of the best fit line. Okay, next we shall learn some proof of the formula in the next class. Okay, thank you very much.